time that we were together.
Fine, I guess. How are you, sir?
Much better, much better. Thank you. I had a non-stopping cough for a while, but now I'm much better.
It wasn't COVID, right, sir?
Yes, it was. Yes, it was COVID,
Oh,
but I got through it quite fast. Luckily, I was vaccinated. I am still vaccinated, so fortunately for that. Otherwise, I'm guessing it would be much more difficult.
I'm glad you feel better, sir.
Thank you. Thank you. Okay, so any questions about the last time that we were together, the last time we had our guests? Uh, any feedback on that? Any comments?
That was wonderful. I think we should have this every year. I mean, not for us. I mean, we might graduate, but for the other students.
You might graduate.
Yeah, yeah. That's
Okay.
the best I could do,
I,
sir, in this
I
school.
I like the optimism. Okay. Yeah. Well, it took a lot of begging and asking, but eventually they were convinced to participate. I mean, otherwise it is almost impossible to convince them to come physically to campus. But now, luckily, we have our courses online, so it is much easier to convince people to just, to participate in a remote session. So it's a bit easier. So I'm glad that it was of benefit to you. So class, we are at the last week of the year. It is almost over. We will be talking about the king of compound patterns today, which is contrary to popular belief. It is not a design pattern. We will be talking about the model view controller triplet, which although people consider it a design pattern, it is not. It is, formally speaking, an architectural pattern. So it is a template solution in order to solve an architectural problem. Now, the model view controller is, as an idea, it is quite old. It is probably 30 years old or something. I mean, it has been around since the original graphical user interfaces first appeared. And there is a reason for that. Now, imagine, just imagine, of course, you weren't alive at the time, but imagine that it is the early 1990s or late 1980s. And these are the times when we have the first instances, approximately, of widely used graphical user interfaces. These are the times when we have the first versions of Microsoft Windows, the first versions of operating systems with that are not based only on a command line interface. Now, this was a paradigm shift. Now, imagine that until that time, during the 50s, the 60s, and 70s, people were almost exclusively preparing applications, maybe small, maybe large, but they were applications that were always based on a command line interface. So they had text menus, they were asking the user for their selection, just like pretty much the programs that you were writing during your first semester when you were using scanf and fgets and whatever in order to read the user preferences and commands in order to react correspondingly. Now, as these graphical user interfaces first started appearing, this was a paradigm shift. I mean, people had to start, and by people I mean the developers, they had to start thinking differently about the way that they approach the development of their projects, of their applications. Now, it wasn't only about a module that was supposed to read data, process data, present the results. Now, this was about having an interface that was constantly there. So it wasn't something that just appeared asking the user for something and then disappeared. It was constantly there visually, a window, a text box, I don't know, a panel, something that was visually there that was supposed to constantly wait for the user to provide some kind of a command, some kind of a feedback. Press on a button, enter a text, enter a piece of text into a textbook, into a text box. I don't know, slide a slider, etc., etc. So you have this component or module in your project now that is constantly waiting for some feedback from the user. And you're supposed to also, of course, have one module at least in order to process the actual data, do whatever the project is supposed to do. I don't know, calculate the factorial of a number, an augmented reality module, calculate Fourier transform coefficients for some reason, who knows, etc. And plus, on top of that, you're supposed to also store somehow your data. Now, if you do not take any precautions, all of these ideas, these principles, these needs, requirements, they can very easily get entangled in such a way that increases the maintenance costs unbelievably. Now, if you do not take any precautions faced with such a problem, what kind of a problem? A problem where you have the task of preparing a visual program which is supposed to be responsive, which is supposed to accomplish a certain goal given some input from the user. And of course, it is supposed to manipulate data. Now, how do you store that data? How do you design that interface? How do you receive those commands from the user? How do you interpret those commands into actual analysis, into actual processing of your data? If you do not take any precautions in order to efficiently, in terms of maintenance cost, in order to efficiently solve these issues, then very probably what will happen is that you will possibly solve the problem and produce a certain output, something that works, but as soon as there is the slightest requirement for a change, everything will fall apart. And by fall apart, I mean you will have to change probably a large number of classes. You will have to modify a large number of classes in order to achieve even the slightest improvement, in order to achieve even the slightest update in that entire system. So this was immediately one of the problems that the developers 30 years ago, they immediately perceived. They said, okay, guys, we need a strategy in order to approach these problems. I mean, it doesn't matter what the graphical user interface is doing. It doesn't matter what the visual application is trying to accomplish. We need to come up with a scenario. We need to come up with uh, some attack rules, some design rules, some architecture rules in order to lay down how we are supposed to approach this type of applications. And the general consensus, the general agreement was that it should be divided into three. And those three components, as some of you already are well familiar with them, are the model, view, and controller components. Now, a summary of today's course in a few sentences is that the model view controller, one, is an architectural pattern. Two, it consists of three design patterns, three actual design patterns that we have already seen, three design patterns coming together. That's all. That's the summary of today's lecture, basically. Now you can all turn off your computer and go. Haha. Okay, now, model view controller. So what is going on? What is the model representing? What is the view representing? What is the controller representing? Now here we have some, there is actually a song. What we have on this page is actually a song written by the authors of this book. In fact, it is even available on YouTube. There is a link somewhere. I'm going to get past this. This doesn't really concern us. Now let's get to the part that is actually useful. Now here you have a YouTube link in case you want to listen to this silly song. So let's get past this. Now, MVC, MVC. Now this was one of the buzzwords that was very, very popular in the 90s and 15 and 20 years ago after the after transitioning to the new millennium. I mean, you could look at any job advert and you would definitely see the word MVC somewhere. So we are looking for a developer who is proficient in MVC. So what is the model view controller about? Now, here we have an example in order to put things into perspective. Now, one of the classic examples of visual applications is, of course, an MP3 player or a song player. It doesn't matter if you're using the MP3 format or FLAC format or whatever. Now, what exactly are the needs in such an application? Now, for one, the view, this is the simplest one. The view component is supposed to represent the visual part of your application. It is what you can see, actually. The panels, the sliders, text boxes, text areas, buttons, radio buttons, check buttons, etc., etc. So in this particular application, you use the view component in order to see which song is being played by the player, in order to see how much time has been left for that song, and so on. Now, on the other hand, we also have the controller. Now, the controller, in this case, it is responsible for reacting. It is responsible for interpreting whatever requests, whatever commands arrive to it from the view. So you click a button on the view. After you click the button, now the ball is on the court of the controller. It is supposed to interpret the meaning of pressing that button and react accordingly. So this is the part where you actually have your functions that actually do the job. Now, of course, you also need some place, you need some component in order to actually store the data, in order to represent the data that you are processing, because no application is worth mentioning if it is not processing any data. And the model does exactly that. The model is supposed to store the state in which the application is in. So is it in the process of playing a song? Is it in the process of stopping a song? Is it in the process of updating the application? Whatever it is doing. That's where you store the state of the application. That's where you store the data. That's where you keep the model, the situation in which the application is currently in. Now, this is only the first example. Some of these things are quite abstract. They might be abstract for some of you. Don't worry. We have several examples. We will take it step by step. And how exactly do they communicate? In which fashion do they communicate? Now, from view to controller, you see the song display update and hear the new song playing. You have a command such as play new song, and you use the interface, and your actions go to the controller. The controller, on the other hand, how does it interact with the model? It is the controller who asks the player model to begin playing the song. So the controller actually manipulates the model. And the model finally tells the view that the state has changed. So if the user has selected a new song, it is the model that will tell the view to now visualize, to now illustrate the new song that is being played. Okay, abstract notions, but let's take a closer look. So the view, the visual part, it gives you a presentation of the model. It is a visual representation of the state of the program. It is the view that usually gets the state and data it needs to display directly from the model. Controller takes user input and figures out what it means to the model. Somebody pressed a button, somebody used a slider, somebody entered some text into a text area. It is up to the controller to figure out what this means so that it will interpret it and transmit that request, whatever it is, that command, to the model so that the model will change maybe to a new song or maybe to whatever. And then the model finally will let the view know whatever that changes so that the view will reflect the current model, the current situation, the current state of the application. So these are the steps that you can encounter in an MVC architectural pattern. Let's go slowly. So number one, you're the user, you interact with the view. You only interact with the view. The user of the application always and only interacts with the view. But as you interact with the view, it is the controller who receives that interaction and it asks the model to change its states. Now the controller can also directly ask the view to change. So it doesn't interact only with the model, but the controller can also interact directly with the view. The user, however, only interacts directly with the view. Now the model, of course, after it is done updating itself, changing to the next stage where it is supposed to be located, so playing the new song or playing a previous song or maybe shifting through the playlist, then it notifies the view that its states that its state has changed. And of course, the view can also ask preemptively for the model in order to get information on its current state. So these are the possible arrows that you have between the three components of MVC. Any questions about these arrows?
For example, can we have an example of the controller affecting the view directly, for example, just something not so abstract?
The controller affecting directly the view in order to change something, something that will not require to modify the model at all. In the case of the MP3 player, what could it be? What can you do to an MP3 player that
I was thinking changing maybe a button, like the play button becoming like 2 bars and then becoming a triangle again. I was thinking something like that, but I'm not sure if
but still that requires you to update the model. That is a type of information that you would keep in your model. Something that would not require to update the model at all. Well, it's been a long time since I last used an MP3 player, so I'm trying to figure out what I can do to it.
It's all right. I'm sure we're gonna see something in the example.
Well, something that is completely visual, something that doesn't concern the data, something that is completely visual, based on appearance. I don't know, maybe changing the theme, but no, the theme also is a piece of information that you would keep in your model. Enlarging some text area, modifying some part of the graphical user interface.
Oh yeah, that makes sense without altering the content.
I mean, that has nothing to do with the content. I mean, you can make it large, small, etc. Yeah, that's a weak example, but it's all I can think of at the moment.
I got it, no problem.
Okay. So what happens when we look at the MVC architectural pattern from the point of view of design patterns? So which design patterns are actually coming together in order to form MVC? So this is a part that you can use in your interviews. So if anyone ever asks you about MVC, which I find it well, a bit improbable nowadays, but formally speaking, from a theoretical point of view, it is strategy, composite, and observer that come together in order to form actually MVC. So how does strategy take part in the case of controller? The view and controller implement actually the classic strategy pattern. This means the view is an object that is configured with a strategy. The controller provides that strategy. The view is concerned only with the visual aspects of the application and delegates to the controller for any decision about the interface behavior. So using the strategy pattern also keeps the view decoupled from the model because it is the controller that is responsible for interacting with the model to carry out user requests. And the beauty of it, the best part of it, is that the view knows nothing about how it gets things done. So when you press on a button, all that the view knows is that it is supposed to invoke a certain function in the controller. But what that function is supposed to do, how it is doing whatever it is supposed to do, the view has no idea. So maybe there is a play song button on the view, and you click on it. And all that the view does is that it goes to the controller and it clicks on controller.play. It invokes the controller.play method. However, that controller.play method, is it going to play the song through the I don't know, through the speakers? Is it going to play it through who knows what kind of electronic equipment? What kind of notes it is going to use? What kind of strategy? What kind of techniques? No idea whatsoever. All that the view knows is that when that button is clicked, it is that function, that method that is supposed to be invoked. And this is precious for us. This is valuable for us because this means that these two components, the controller and the view, the action and the appearance, they are distinct from each other, which means they can change without affecting one another. So you can change the view. One day you can have an old skin for your MP3 player. The other day you can update it. One day it can look like a command line interface. The other day it can look like some fancy graphical, I don't know, who knows what they're using nowadays. I don't know. It could be a Spotify interface even. Maybe you're even manipulating through your TV. Who knows? But the main idea is that they can change without affecting one another. You can change the strategy, the way that you play the song without affecting the view. You can change the visual appearance of the application without having to change whatever code is being executed behind the scenes. So that's the beauty of the strategy. Just like identically to the way that we were changing the way that the ducks are flying without actually affecting the main duck class. Main idea, exactly the same. Now, what about the observer? Now, the observer was a design pattern that we were using in order to establish the communication between the observer and the observable. And the main idea was that there was the observable, the subject, and whenever it changed, it notified the observers. And we could have many of them. It was a one-to-many relationship. One observable, many observers. Now, where exactly do we have the observer pattern in this particular example? Now, the model implements the observer pattern to keep interested objects updated when state changes occur. Using the observer pattern keeps the model completely independent of the views and controllers. It allows us to use different views with the same model or even use multiple views at once. Now, the beauty of this part is that, I guess the classic example for this particular case would be changing the theme, the visual theme of your application. So you could use different skins for your graphical user interfaces, different themes, but as long as the model is decoupled, it is distinct from the view, no problem whatsoever. You can change the view as you wish, but no matter what kind of an appearance you still have the same concepts in your view. You still have a play song button, you still have a pause button, you still have a stop button, you still have a fast forward button, and so on. And the view here, for instance, these two arrows, they are specific to the observer pattern. So the view can, for instance, request the state information of the model. As you will remember, we had two strategies in the observer design pattern. We had the pull strategy and the push strategy. So both of them can be very easily implemented in this particular scenario. The model can notify the view that it has changed, and also the view can request the state of the model. And on the other hand, we of course have the composite. Now, the composite, we will see it in detail in the upcoming slides. The main idea is that no matter which framework you use in order to develop your graphical interfaces, whether you use the old abstract windowing toolkits or the Swing libraries or JavaFX or whatever libraries you use in .NET and so on, all of them, with almost no exception, they are using a tree hierarchy. They are using a hierarchical representation in order to store the visual components on an interface. What do you have in an interface? What do you have in a window? You will have the panels, large rectangular areas. Those large rectangular areas will contain probably smaller panels. Those smaller panels will contain some components such as text boxes, buttons, radio buttons, check buttons, and so on. And if you try to visualize the organization of these components and panels, you will see that you have two kinds of objects there. You either have containers, such as panels, that contain other panels and eventually end components, such as text boxes. And of course, you have the non-container objects, such as text boxes and buttons, that are actual visual components. And so you can imagine it as a tree where the leaves of that tree represent the end components, such as text boxes, buttons, and so on. And of course, you have the inner nodes of that tree, which actually represent the containers. And so we basically obtain a structure that is identical to the composite design pattern. The same idea that we had with the email addresses, where an email address could be a group address representing other email addresses or other group addresses, or an email address could be a personal, an individual email address. Same idea here as well. A visual component can either be a container containing other containers and components, or it can be a leaf component, an end component, which doesn't contain other components, such as a text box, a button, and so on. And thus, we have the composite design pattern uh, taking place in the view corner of the MVC architectural pattern. Any questions about these three patterns? Strategy, composite, observer?
Some of the modern web development frameworks, they have something called MVC, like called the same way, model, view, and controller. Are they like different flavors of the same thing, as far as you know?
Same idea exactly.
All right.
Same exactly idea. The only difference is that instead of having a standalone desktop application, they are web-based applications. But you still have a visual component, you still have the controller taking care of reactions, and of course you have the model storing state information and data. Same idea exactly.
Very good.
That's why MVC is still well around and happy. Excuse me. Now, an even closer look. Now, the observer design pattern. What do we have exactly? Who is the observable? Who are the observers? Now, the observable is, of course, the model. And whenever the state changes in the model, so for example, you have switched from one song to the next, for example, it has to notify the view or more than one views so that they will update their interface. So can you tell me the name of a song? Any song?
Üsküdar'a giderken.
Okay, one more. The name of a second song?
Beat It, Michael Jackson.
Okay, Mr. Alp. Why not? Why not? Two perfectly beautiful songs. So if the user has switched from Üsküdar'a giderken to Beat It, when will the name of the song change on your interface? Who will change it? Now, the controller has received the request from the user to change the song. What does the controller do? The controller goes to the model and it makes the modification. It tells the model that from now on, you will not play Üsküdar'a giderken and you will play Beat It by Michael Jackson. And the model does that. The model updates itself so that from now on, it is playing song number 2. And then somebody has to also update, of course, the view so that the user using the actual MP3 player will see that the song has actually changed. And the model plays the role of the observable, and it calls very easily the notify observers method. And whichever components, maybe one view, maybe two, whichever components are observing this model, they get notified and they update correspondingly their interfaces. Now, of course, this doesn't mean necessarily that you have only one view. You could have one model which the user is experiencing through, maybe you have 3 users connected to it, and one user is using his tablet in order to access this application. Another user is using his desktop computer. Another one is using his smartphone. Another one is using his television. I mean, televisions also support applications such as Spotify. So you can have the same Spotify model that the user is accessing through his or her phone, tablet, television, and so on. And whenever the same user is changing the song on Spotify, and all of these devices are open, so television, tablet, phone, and so on, desktop computer, they will be updated, all of them, in order to show the current song that is played. Why? Because very easily, the model has invoked the notify observers method. And all of these devices are in fact observers. So they will be notified and update themselves correspondingly. Any questions about the observer and how it takes place in MVC? Okay. And here we have strategy. The view delegates to the controller to handle the user actions. So the user actions, they are received by the view. It is the view that receives whatever commands the user has given it. The view does not interpret any of those commands. It doesn't care what the user has wanted. All it does, it just transmits them, it forwards them, it delegates them directly to one or more controllers. And it is the controller who will know how to handle those user actions. And where is the strategy? The strategy, the beauty of strategy is that we can always change the controller. You can have one controller that will interpret the pressing of a button in order to exhibit a certain action, and you can very easily change it the next day with a different controller module, which will have a different set of reactions for the same buttons, check buttons, radio buttons, and so on. So as a result, we get a beautiful modular structure. The advantage? Oh, one of the advantages is that once you have coded and developed a certain application using this architectural pattern, it means that if your requirements change, but some parts of this application you can still reuse. For example, you have a new application that requires a new controller, but the view that you had used for a different project is still useful in this context. So what do? You take the view readily available from your past project, and you only update the controller. And voila, you have a new application that does something different, but it has the same appearance as the previous one. Or alternatively, you can keep the controller constant, so an application that does the same thing, but it is a completely different view. It's still beautiful. You have only had to code the view, and you are still using the same controller and model. That is the advantage. Code, reuse, a modular structure, ease of maintenance, ease of updating. And of course, since you will spend less time in order to update it, that means you will have more time in order to do more things for your boss so that he or she can earn more money. And of course, composite. Well, here you can see, as I have previously explained, the hierarchical structure. At the root, we can see the entire panel representing the entire window, which contains as children nodes the different components, the label, the buttons, and so on the view. So the top level is the top container, and as you progress towards the leaves of the tree, you encounter the end components of the visual interface. Nothing fancy here. Now, let's look at a different example. Using MVC to control the beat, I am guessing that there are no DJs or DJ wannabes among you. When I was a teenager, for some reason, in the 90s, being a DJ was supposed to be very cool. So I had all these friends in high school that were talking about how you should use gold-plated connections in order to get better audio output. There were these guys that were dreaming of becoming DJs and clubs and so on. It was an interesting period, to say the least. Now it is your time to be a DJ. Now, DJ is short for what? Any ideas? Without looking into Google?
Is it a digital something?
No, it is not a digital something.
Okay, this something.
This jockey. Okay, somebody is fast with their Google game. Okay, so it is your time to be the disc jockey, the DJ. So when you're a DJ, they say that it is all about the beat. So the reason why they used to pay a lot of money to DJs in the past, because it took quite a lot of skill to pass from one song to the next, from Üsküdar'a Giderken to Beat It by Michael Jackson. So you had to make the transition smooth so that people could still continue to dance without falling off rhythm. So that was the difficult part of the DJ's task, because otherwise it is just about switching from one song to the next, picking songs That is not the deal. The problem is how do you switch from one song to the next without people falling off rhythm. So that's why here it says, when you're a DJ, it is all about the beat. You might start your mix with a slowed down tempo groove at 95 beats per minute, shortened as BPM. And then you can bring the crowd up to a frenzied 140 BPM of trance techno. Wow, there used to be a time when people used to listen to trance techno. Okay, and then you finish off your set with a mellow 80 BPM ambient mix. Now, how do you design this interface? What kind of components are you supposed to have in order to control these BPMs and so on? Now, we have two views here. Our view, our application, very simple for now, will only consist of two views. So we have one very small window, which has a pulsing bar, pulsing from left to right, in order to show us the beat in real time. So at every beat, the blue part increases, it enlarges towards the right. And of course, it also has a label showing the numerically the current beat at the moment. Now, the second window is where you actually enter numerically the BPM. You actually enter the number of beats per minute. You click on set and that's it. And then you can also use, if you want to, the two buttons below it in order to decrease it or increase it as you wish. So these are the operations that are supported. Setting the BPM, increasing it, decreasing it, and of course, visualizing it both numerically and with a pulsing bar. That's it. So the view is very simple. Well, we also have a small menu here in order to start the beat, in order to start whatever song is supposed to be playing, and of course, in order to quit the application. Now, of course, once you click on start, it will be deactivated, and of course, the stop option will be activated. Now, who's supposed to be doing all this stuff? Well, that is up to the controller. Now, that was the view. That was the view. Now, what about the controller who is in the middle between the model and the view? Now, the controller sits between the view and the model, and it takes your input, such as selecting start from the menu, and turns it into an action on the model in order to start the beat generation. So what does the controller do? It interprets the commands received by the view, and it reflects, if there are any changes, it reflects those changes onto the model, such as, changing the BPM and so on. Now, what about the model in this case? Where exactly is the model? Now, in this particular example, the model is not something that we can see, of course, but it is underneath everything else. It is managing the beat and driving the speakers with MIDI. Does anyone have any idea what MIDI is?
It's basically code that is translated into music.
Yes, it is. It's
quite.
Yeah. Yes?
And it's universal. You could translate any instrument into anything else.
Yes, that is true. It used to be the only option that was available in the 90s during the songs that you could play on your computers, the audio that was available during the games, and so on. But fortunately, afterwards, we were blessed with stereo sound. Now, the beat model, what kind of information is it supposed to contain? What are the state parameters that we are supposed to store in order to keep this application going? Now, naturally, of course, we need to store the current beat per minute, the current BPM. And of course, the model will be affected by methods such as set BPM and get BPM. It will be affected by the methods on and off in order to start the model, and of course, in order to turn it off. So we need support for operations such as increasing the BPM, decreasing it, and of course, setting it directly. Now, if we try to put all of these pieces together, what will happen? So the beat is set to 119 BPM, and if you want to increase it to 120, you can either enter it directly to enter BPM, or you can simply click on the increase button. Now, if you click on the increase beat button, this command, this request will be received by the controller. The controller will interpret the pressing on the button. The user wants to increase the BPM. It is the controller that will interpret it, not the view. The view has no idea what that button means. All it knows is that if I click on that button, I must invoke a certain method in the controller. That's it. The controller who interprets the controller function that has been executed, invoked, knows that the user wants to increase the BPM. So what does it do? It interacts with the beat model. It lets it know that the BPM must increase. So whatever it is now, I don't know, 119, it needs to go to 120, or by half a beat to 119.5 or whatever. And after the model has been updated, it is the model that notifies the observer. Who is the observer? It is the view, one or more. It notifies the view that the beat per minute has increased, so that it will illustrate, it will show whatever is the current BPM at the moment. This is a classic transition of what? A transition of responsibilities in the MVC pattern. The view receiving the request, the controller interpreting the request, the controller letting know the model how it is supposed to change, and then the model notifying the view so that it will update itself to the latest stage. Okay. All of this, of course, is stuff that we talk about, but we haven't seen any code yet. So let's start looking at the code. So we are supposed to see the observer design pattern, the strategy design pattern, and the composite design pattern, all of them together. Let's see what is going on. We have an interface. Now, this interface contains all the operations that are supported in the model. Now, remember, the model is the subject, the observable. That means it needs to register observers, and also it needs to be able to remove observers. And of course, it should be able to notify the observers. As you will see, we have two couples of register remove observer methods. Why? Because we have two view components. We have two view components that need to be updated, need to be notified. So I have two couples for them, one for the beat observer and one for BPM observer. We, of course, have the initialize method, the on-off methods, setting the BPM, getting the BPM in case the view requests it or the controller requests it. So these are all the operations supported by our model, plus the register remove couples in order to be able to manage whichever views are observing this model. Okay, any questions about the model interface? And now the concrete model. Public class beat model, which will implement the beat model interface. And additionally, it implements the meta event listener, which is only there in order to be able to play the songs. So this is the interface that we need in order to actually play MIDI code. Now, what does it contain? It contains a sequencer. So this is for the meta event listener, and array list containing the beat observers, and array list containing the BPM observers. It has also an integer holding the current BPM, and of course, any other instance variables that might be necessary. Now, naturally, of course, all of these fields should have been what? They should have been private. Always private, unless you have a reason for it not to be private. But your default option is to always make the fields in your classes private. You only modify it if you have a reason for not making it private. Always. Keep it as hidden as possible and only show it to the outside world if you have a reason for it. So we have the initialize method, which just prepares, the MIDI engine in order to start playing the songs. Now, the MIDI engine, of course, is interacting with the sound card on your system. And of course, the sound card is going to interact with the speakers. So it needs to be ready to receive the musical notes. So once you click on once you invoke the on method, it makes sure that the sequencer starts executing, and it sets the BPM, the beats per minute, to 90. By off, it sets them to 0, and it stops the sequencer. By set BPM, it simply sets the BPM directly, and it notifies the BPM observers. So all the BPM observers are notified that the BPM has changed, so they can pull the current BPM value and show it on their graphical window. Any questions about the concrete beat model?
Here, is there a good reason we're assuming there might be a lot of views? Because we know for a fact that we have two, one for BPM and one for one for the number, one for the bar.
So you're saying that instead of having an array list, I should just keep the single reference?
Yeah, I'm saying, is there a good reason that we kept it an array list?
As opposed to having a single instance.
Yeah,
instead of a list.
since we have only two views in a user can handle.
Well, you can always register additional views there, because at the current state, even if you have 100 additional views, all you have to do is just call the register observers method in order to register the new observers, and the rest of the code will operate as it is. So it will notify not one, but 100 observers, and that's it.
Right.
So it is just for, in order to make sure that it will be able to support additional observers in the future.
Okay, thank you.
But if you are really certain that you will need only one single observer for all times, well, in that case, yes, of course, why create an array list when a single reference can do the same job? But of course, you will always be afraid of the day that will come when the user will say, yeah, Mr. Alp, I like this application a lot, but could you add just one more window doing this additional thing? And you will go like, why didn't I have an array list?
It's evident.
Now I have to change the model too. Yeah. Okay. Now, class, before continuing to the view, we will take a break for 10 minutes. I need to drink some tea. And we will continue at 14:28. Okay. I'm stopping the recording.